Your Python program just crashed. A red wall of text. Traceback. Line numbers. Error names you've never seen. That happens because Python hit a problem and had no instructions for what to do next. Exception handling is those instructions.
Hay majas.
This is episode 32, exception handling. Try, except, else. Finally, raise, custom exceptions.
Exception chaining.
By the end of this video, your programs survive the real world. Let's go. Try and except are your first safety net. Without them, one bad input crashes everything. Watch this. We divide by 0. Zero division error. Program dead. Now wrap it in try and except. Try run this code. Except zero division error. If this happens, do this instead. The program doesn't crash. It handles the problem. Keeps going. One rule to remember. Never use bare except : with no error type. That catches everything, including keyboard interrupts. Always name the specific error. Different errors need different responses. One try block, multiple except blocks. Watch this function. It opens a file, parses a number, divides by it. 3 things that can fail. 3 different ways. FileNotFound error, the file doesn't exist. ValueError, the content isn't a number. ZeroDivisionError, the number is 0. Stack them vertically. Python tries each except in order. First match wins. Put the most specific exceptions first. Put the broadest at the bottom. You can also catch multiple errors in one except. Except bracket ValueError, comma, type error bracket. Handle both the same way. Else and finally are the 2 most skipped keywords. Else runs only when no exception occurred. Think of it as, this code only runs if try succeeded. Use else for code that depends on try working. Not for cleanup. Finally runs always. Exception or no exception. Even after a return statement. This is where cleanup lives. Close the file. Release the lock. Log the result. The classic pattern. Try do the work. Except handle the error. Else success path. Finally cleanup always. Raise lets you throw an exception intentionally. This is not a mistake. This is a design decision. You have a function that expects a positive number. Someone passes -50. Don't return none and hope the caller notices. Raise ValueError quote amount must be positive. Now the caller gets a clear, named error immediately. Not a silent wrong result 3 functions later. You can also re-raise inside an except block. Just write raise with nothing after it. That preserves the original traceback and lets the error bubble up to whoever can actually handle it. Let's do a live crash and fix. Watch this program break on screen. Then watch it get fixed line by line. We have a function that reads a config file, parses it as JSON, returns the API key. 3 things that can crash it. Step 1. FileNotFound wrap and try, catch FileNotFound error. Step 2. Bad JSON format, add except JSON.jso ND code error. Step 3. Missing key, add except key error. Step 4. Add finally close resources. Watch the red traceback disappear. Watch the green handled output appear. This is the exact transformation you'll make in real code. Quick 30-second favor before we keep going. Did that crash to fix make sense? That red to green moment? This channel is completely free. 1 subscribe helps it reach more people stuck staring at tracebacks right now. Tap it. 2 seconds. Okay, back to it. Custom exceptions up next. This is where senior developers separate themselves. Custom exceptions are your own error types. Built-in exceptions are generic. Your code deserves specific errors. Here's how. Class insufficient funds error inherits from exception. Add an __init___ with amount and balance. Format a clear message. Call superinit with that message. Now raise insufficient funds error, amount, balance. The caller gets a specific, readable error. Not just value error or runtime error. This is why every major library has its own exception classes. Requests.connection error. Django. Does not exist. Your code should too. Start simple. Just inherit exception and add a message. Every exception in Python sits in a tree. Base exception is at the top. System exit, keyboard interrupt, and exception branch from it. Almost everything you deal with is under exception. lookup error, then index error and key error under it. OSError, then FileNotFound error and permission error under it. Value error and type error sit at the same level. Why does this matter? Because except OSError catches FileNotFound error too. Parent class catches all its children. Put specific children first in your except blocks. Put broad parents last. And never catch base exception. That would catch keyboard interrupt and system exit, blocking your program from responding to Control-C. Exception chaining preserves the original cause. Here's a real scenario. You catch a low-level database error. You want to raise a high-level application error instead. Without chaining, the original cause disappears. With chaining, it's preserved in the traceback. Raise app error "database unavailable from the _original exception. Now the traceback shows both errors, the direct cause and the original trigger. You can also suppress the chain. Raise app error "message from none." That hides the original. Use it carefully. You're choosing to hide information from the next developer. Python 3.11 added ExceptionGroup. This is for async code that runs multiple tasks at once. When several tasks fail simultaneously, you need all their errors, not just the first. ExceptionGroup bundles multiple exceptions together. To catch them, use except star, not except. Except star value error as e.g. now e.g.exceptions is a list of all the value errors. You won't need this until you're deep in Asyncio. But when you are, this is the only clean solution. 3 patterns that look like exception handling but aren't. First, bare except : catches everything, including system exit and keyboard interrupt. Your program won't respond to Control-C. Always name the type. Second, swallowing errors silently. Except exception pass. The error happened. You hid it. Now it will surface somewhere else, hours later. Always log or re-raise. Third, using exceptions for normal control flow. Don't try something just to catch a predictable failure. Check first with if. Exceptions are for the unexpected, not the if-else. Mini project, a robust file reader. Real-world requirements. It needs to survive 5 failure modes. File doesn't exist. File not found error. No permission to read. Permission error. Not valid JSON. JSON.json code error. Missing key keyer. Wrong value type. Type error. Each error gets its own handler. Each handler returns a safe default instead of crashing. Finally, always logs what happened. This is the exact pattern used in every production config loader, every API client, every file processor. Your challenge: write a function called safe_divide. It must handle ZeroDivisionError, type error, and value error. Add a custom exception, negative input error, raised when either argument is negative. Use else to print the result on success. Use finally to always print "done." Paste it in the comments. I read every single one. Let's recap. Try and accept your safety net against crashes. Multiple except blocks handle each error differently. Else code that only runs if try succeeded. Finally, cleanup that always runs. Raise, throw exceptions intentionally and clearly. Custom exceptions, your own named error types. Exception hierarchy, specific before broad. Exception chaining, raise from preserves the cause. And the most important lesson, never swallow errors silently. Log them, re-raise them, or convert them. Next episode, comprehensions list, dict, and set in one line. Subscribe so you don't miss it. See you tomorrow.
Exception handling unlocked.
Your programs can finally survive the real world. Try, accept, raise custom exceptions. This is what production Python looks like. Subscribe for the next episode. Drop your safe_divide in the comments. I'm Mahaz. See you in episode 33.